morning, everyone. Yeah, it's a great pleasure for me to be here again. So last year was my first time here, and this year now I have another opportunity to talk about some nice stuff. So I called it Another Place, Another Time, and telling a little bit about GPS insecurities, the threats that are in GPS, and what can happen. So we have a short introduction about that, have an overview about what is global navigation satellite systems, a short overview of autonomous systems. Then we take a deeper look into the threats and some kind of countermeasures that we can do. So there are some protective things that we can have in place. So yeah, everybody use it. But most of us don't know exactly how it is working. So that I try to explain a little bit more. We have so many names: GPS, Navstar, Galileo, GLONASS, Baidu, IRNS. What's behind those words? And there are some different, but all of them are, have the same background. It's called the Global Navigation Satellite System, GNSS. But yeah. So my name is Stephan Gerling, as already said. You find me on Twitter under Obi1666. I'm older than the internet, by the way. Some certifications I have. I'm an electronic specialist and was working in the German army for navigation systems on helicopters. So that I did 7 years there. Was a nice experience. And by the way, I'm also a firefighter, a volunteer firefighter in Germany since 32 years now. It's one of my passions. And in our company, I'm doing all those security things that are not fitting in the normal security departments. By the way, I always avoid warranties. I buy stuff, try it out, open it, and want to know how it is working. And I'm volunteering also in some groups. One is our hacker group called Geraffel, and another one is I'm the Cavalry. So it's an international group where I involved in the maritime security section because of things on ships and yachts that I do. So back to that, global navigation satellite systems. All of us name them GPS. So when I say GPS, I don't mean the GPS system from the US. So I mean the GPS system in general. To have not a long word like that. So everyone is using it every day. When you open your smartphone, Google, they're using the location services and so on. When you drive with your car, using the navigation. When you travel with a plane, and even when you travel with a train now, you're using GPS systems. So you have it all the way, always, 24 hours, I say, that you're using it. The names, as an overview now, the Global Navigation Satellite System is an acronym of GNSS. So then we have the Navstar GPS, that's the version of the US. The Navstar is the normal word. It comes from Navigational Satellite Timing and Ranging, Global Positioning System. Very long word. And they introduced then only the last part, GPS. That's what most of us are now using as an acronym for that. Then we have the Russian version. It's called GLONASS. That's a word I cannot really pronounce correctly. So Globalnaya Navigationia Sputnikova Systema. I think it's not good, but yeah, it's a hard word for me. Then we have the German version called Galileo. It means nothing, yeah, as we Germans are. Baidu, the China version. The Chinese people named their GPS system by a Big Dipper system in the a Big Dipper asterism constellation in the sky. And then we have the Indian one, IRNSS. So why we have so much of them? The first one we can take a look at the overview now. So the GPS system from the US were the first one. They started the development in 1973. The Russian started in 1976, then the Chinese with their Baidu system in 1980, and then Galileo started at 1999, and the Indian one in 2004. So the idea behind was the US started the satellite system, but it was exclusively only for the military at that time. They opened it in 1996 for commercial use, and in 2000, I think Bush was it, when so he signed a contract. So normally the precise of the signal from GPS was altered for the private use. So you had a precise signal only by 100 meter, and for the military services you have a precision of about 5.8 meter now. And in 2000, the US government released also the precise signal for the public. So the idea behind this was they want to hinder the Galileo system becomes famous. So that was the idea behind it. The good effect is that all the satellite systems are now very precise and everyone can use it. Another thing why we have so many things of them is no country want to rely on a GPS system of another country. So why would Russian military services rely on a US GPS system for positioning? So that's why they have their own one, even the Chinese one and the European ones. So that's why we have so many systems in place. By the way, each system of that has around, at minimum, I think, 24 satellites. The GPS, the NASTAR GPS has now around 31 satellites in place, and there are 2 other satellites in the orbit, but not operational yet. The Galileo system has now 24 satellites active, so you can use it worldwide, but still in an initial phase. So they will become full operational in 2020, so next year when the last 6 satellites are operational. So in full, we have then 30 satellites for the Galileo. For the other ones, it's similar, so you have to have around 24 satellites and a couple of spare satellites when something has happened or when they update some. This, as a short overview, we will need it later. I show it later also again. So there are a couple of frequency use, but you have, I think this is the laser pointer here, didn't? Yeah, but you don't see it really good. So here we have the L1 band. That's where all the private navigation systems are running. Then we have an L2 band. That's a special band where some of the search and rescue services are running, some of the military services are running, and most other military services are running in the L5 band. So privately using, we're only using this L1 band. So that's mostly enough to know about that. So all the frequencies we see later, and here as a normal chart now. So we have a couple of them, and yeah, everyone using different frequencies for that. So when we see now here the orbit range, we see the ISS is around, it's not that high, 300 kilometers, I think. But when you're looking here for the satellites and which kind of orbit they are running, so it's already 20,000 kilometers and more. And that's also why the signals are very weak. So a satellite is sending the signal with more or less than 1,500 watt of signal strength. But what you receive on the Earth is only a few milliwatt. So it's a very weak signal, you can say. So the receiver has to amplify it, and that's also a reason why it is easy to override it with spoofing, that we will see later. And you need at least three satellites in line of sight. So when you're staying here and when you see 3 of those satellites in the orbit, you receive the signals from them, and by calculating from the sending time and the receiving time, they calculate the position of that. If you want an exact timing of that, you need already 4 satellite system signals. So with 4 satellites, you receive a precise timing and a precise position. Then we have the autonomous systems. So all of those things are relying more and more on GPS systems. Self-driving cars, bus, trucks, trains. Everyone has to know exactly in which position are they now. So they're using GPS for that and some other information. Sometimes Wi-Fi, sometimes Bluetooth information, some other aerial information with LiDAR or something else. And even ships. It's a little bit difficult, but ships only rely on GPS information. They don't have anything else. If they have no GPS signal, they have to navigate by hand. So they're using their old charts and a star constellation, and they're looking up where they are. But when you have a cloudy day, you don't see the stars and you cannot navigate at that time. But other industries are also using GPS. So the finance sector, using the precision of the time stamp of the signal, for example, to synchronize all their systems for stock exchange, power grids, industrial power plants, pipeline operators, cell phone towers, and so on. We see it everywhere. I show you a couple of pictures there. This is a cell phone tower that I've seen in China. It was standing there just open at the street, so everyone can plug on the cables. You see here the fiber optic cables, but you see also here 2 satellite GPS antennas. So even the cell phone tower using GPS signal, for what reason I don't know, but they have 2 antennas in there. This was a test from Thales this year, I think in September. And it was an autonomous train. It was driving the first time autonomous, and the operator you see on the below picture there was sitting on a different place and remote controlled the train. So for that, he has to know where is the train right now. And they operated in real time the control of the train with 5G networks. So Vodafone and Thales did the test there to show that 5G network is fast enough to operate a train in full speed for that. Then we have autonomous ships. So Rolls-Royce did 2017 the first test where they operated it was a small tug, 28 meters, and they put some electronics in that they can remote control it. For safety reason, there was a captain on board that he always can override the system. And so they undocked their system from the pier, turned around a little bit in the harbor and make a 360 degree and maneuvered back to the pier where they started from. That was the first showcase how they showed up. It is possible with that. But for that, they always need satellite communication for internet access and remote control. And the other thing that they need exact positioning information about where is the ship right now. Yachts. They have it also. This is a picture from Sochi Harbor, where I showed some of the GPS antennas. There are 2 different yachts here, and at least everyone has 2 or 3 or 4 GPS systems on board. Why? I tell later. Because of electronic maps on the ships. In the past, we had paper charts for the rivers, for the high sea, and so on. With these charts, you had to navigate. So nowadays, you can have electronic charts, so electronic navigational charts or digital nautical charts. When you're using this, you need at least 2 or more independent GPS receivers, and then you can rely completely on the ACDIS. So it's an electronic chart display and navigation information system. So when you have that in place, you don't need this paperwork anymore. But you are completely relying on electronic information systems that are connected somehow to the network of the ship. You need internet access, and you need precise information about the satellite system. The thing what's not really clear is independent, so you need 2 different GPS receivers, but it's not saying you need 2 different system of GPS receivers. So you can have 2 or 3 NAVSTAR GPS receivers, but the better way should be you need 1 NAVSTAR, 1 GLONASS, 1 Galileo receiver. Then you are covering everything, so when that system is falling down, it's no problem. Yeah, all the systems on the yachts are relaying more or less on the GPS signal. So the GPS receiver getting the information of the position and send it to the CAN bus on the yacht. And this signal from the position is then used by AIS system, the vessel traffic services, and for the ACDIS, for the electronic chart display and information service. So all those rely on one GPS system. And another thing is your mobile phones. For example, when you're using Galileo in the European area, there is a website you can use to look up is your phone able to use it or not. Use galileo.eu and then you're fine. So coming now to the GNS or GPS threats. 3 scenarios. When you look Wikipedia, for example, they only show 2, jamming and spoofing. Yeah, jamming is some kind of denial of service, but there is another example that I show later. That denial of service can have also other reasons. Yeah, jamming is quite simple. Just make noise on the frequencies that you want to disturb, and that's it. And for the spoofing, it is a little bit complexer. You can buy specialized hardware for that, or you can use do-it-yourself stuff. So just use an SDR radio transceiver, and then you can build up your own spoofing device to alter with position information and timing. And for the denial of service, that was my third scenario, is you have to have more or less access to the ground stations of the systems. Yeah. Jamming is quite often. Mostly when every time a military exercise or maneuver is done, the military will disturb the GPS signal. So the US is able to alter or shut down the GPS system when they have, yeah, in the case of a war they will do, in military exercises they do also, and the Russians also, when they do there some military exercises, they also alter or jam the GPS signals. So there are a couple of reports that you can look up where they report all the things. For example, in 2017 there was a big report about where also where commercial airplanes reported that they have weak GPS signals, and they figured out it comes from the eastern area of the world. So guess where it is. And the US Navy they stopped with teaching sextant navigation in the past because they said, so hey, we have GPS system, we don't need to navigate with a sextant anymore. But after they figured out a couple of years ago that it's not that reliable as they wanted, so they started teaching again their captains with alternative navigation systems. By the way, the first training of them were held in Germany because the German Marine captains always training six-stand navigation. For jamming, we need this chart again because it's very easy to just jam only one system. So when we want to jam the GPS system, the NAVSTAR GPS system, we only need 2 frequencies. Then we're done. The same is for the GLONASS system, only 2 frequencies, and then we're done with jamming for them. So you see also here, when we jam GLONASS, GPS is still working. And when we jam the Indian ones, all other tools are still working. Coming to the Chinese version, they already have 4 frequencies that they use, and the European version is using 5 of them. So when you want to disturb the Galileo system, you have to jam 5 different frequencies. And some of them are similar to the other systems. So 1500 75.42 megahertz you find also in the GPS, and GPS and Galileo using some frequencies the same, but not all. Also Baidu using this. How you can do it? Just go to an online shop, buy a GPS jammer. They are not expensive. Yeah, okay, this one a little bit, so 330 bucks. Or 45 bucks, 180 you see here, but you can also have it for $80 as a USB device, and that jams GPS signals in your area. You can have it with a battery power backup, or you can have it for your car when you don't want to be tracked by someone else. Maybe police services are using GPS tracker to looking up your car where you are traveling to. Using those cigarette lighter GPS jammers, they don't have an idea where you are. Spoofing is a little bit complicated. So specialized hardware is in place, like this GNSS simulator from LabSat. It's quite expensive, 15,000 euro you pay for those devices. But you can also rent it for a couple of weeks to test with them. What you do there, you simulate a navigation satellite constellation and then sending the signals, and then you can test your receivers how it is working. We had a couple of things of them in our office, so it's very easy with that kind of system to work. But you can do it also yourself. All you need is a software-defined radio transceiver. I use a HAC RF and a special antenna for that. You see here it's a GNSS antenna for GPS and GLONASS. Or you can use another one, it's a blade RF. It has a little bit more power. You can use 4-channel sending and receiving at the same time. The HAC RF can only send or only receive. When you want to do both, you need 2 of the HAC RF. When you use the blade RF, you can do it in once. So that one thing to remember, don't alter or mess with GPS signals, because sending signals is always a violation of some laws. Using a testing environment, for example, a good shielded office for that, or using your Faraday cage like a forensic bag for that, it's also good working for that. Then you can test if it is working or not. All things you then need is just kind of piece of software. Go to GitHub, download the GPS SDR simulator software, and it's working with Aldam Pluto device, with the Blade RF, with the HAC RF, and some other devices. So everything you needed is just there. Download it and use it. What we else need is every day we need to write M-Ferris file of the constellation about where the satellites at that day are. So that you need, that you have correct information which kind of satellites you want to override. When you just do it with some sample information, it will not work really, because your receiver is receiving the signal maybe from 3 satellites, and you're spoofing the signal from 4 other ones. So that's not a good idea. So therefore, you need the daily M-Ferris files. Then you have to write. Then the software has to write information about which satellite they will spoof. Because every satellite has a unique ID from which the source is coming. Yeah, so with that, we can prepare our simulation file. So you maybe send some waypoints, put some points on the list, and then you have to compile a simulation file from that. And these binary files you're then using to transmit with the HackRF. It sounds very hard, but you only need to set the frequency that you want to spoof, the sample rate, the right one, the bandwidth, some other static information. Then the good one is here. You need a config file with the GPS sim bin binary file. So this is the binary file that we compiled with the right Ampheris file. And then just say start, and it's working. What else we can do? On ships, when you have physically access, you can also play with an NMEA generator. So you need access to the NMEA network, and then you can send faked signals to the bus system. It's, yeah, but it's required physical access to the system. The third one, what I mentioned, was the denial of service. So Galileo had in July this year an outage about 11 days, so more than a week. Why it was happened? So normally, nobody recognized it in front, because when you're using Galileo and it's shutting off, your mobile phone is using something else, GPS or GLONASS. So it's no problem. That's a good reason why we have so many systems in place. So you have always a reliable information about your position. So at that time, the Galileo system was completely shut down. No satellite was sending any more information. The not official root cause, because nobody said a real word. So to have an exact timing and position information, you need to have a precise clock. So each satellite has an atomic clock on board. And for synchronization, there is also an atomic clock on the ground station. So in the Galileo system, one is in Fucino in Italy, and the other one is in Oberpfaffenhofen in Germany at the DLR. So what happened? The service technician in Fucino recognized, okay, one of our atomic clocks in our system is not working really good, so we go in maintenance mode and try to fix that. What they don't know was that in Germany, at the same time, they switched off the atomic clock for maintenance reasons. So it was a management problem. They don't talk or communicate in a good way for that. So, yeah, that happened then. So even then, 2 atomic clocks are not there. So a couple of hours, it is no problem that the satellites are sending the signals again. So, but what then started was the coordination to get back in operational mode was too long, because too many parties are involved. Everyone wants to say, so, oh no, we have to do this one first. Oh no, we have to do this one first. No, we are in charge. We are the leader of the recovery. And then it happens, then it takes over 1 day, and then all satellites starting to stop sending any navigation information. Yeah, the synchronization of the clock stopped, the satellite stopped operating, that's it. So the Galileo was not working. 2 days later, they reported on their website, it is not running. So I have also the link of the advisories from the GSA website, where you can look up the exact dates and other information if you want. Yeah, and then the other thing is the search and rescue services were still working because they were working on a different band. So it's a L2 band, as I mentioned in the front of it. What we can do for that, to prevent such things. Some countermeasures we can use in your receiver. We can use signal strength change detection. So when the signal strength is changing, then it can already a hint about, okay, someone is spoofing your signal. When it is maybe stronger than it supposed to be. Plausible checks on time jumps. When you have time jumps in your timing synchronization, then in your receiver, then it can also be a hint about some altering of that. You can use some kind of wiggling antennas. So when you have a wiggling antennas, it's simulating that you have two antennas, and then you can calculate from that, for example, different signals, but it's not really reliable. But someone were already testing with that. Or you compare your signals with different systems. Another nice thing is the Galant from DLR in Germany. So they have here an antenna array. This small box here is 2 by 2 antennas. So here we see the signal. And because of that, you can calculate from the signal strength from which side the signal is coming. If it is coming from a side and only one antenna or two antenna has a stronger signal than all four when it's coming from the orbit, then it is already an hint someone is spoofing this information. And the antenna is also active, so it can, for example, when the spoofed signal is coming from here, they can lower the signal here in the amplifier and then letting pass through the original one from the orbit. Or you can buy a GPS firewall. It sounds like the snake oil of the 2020s, but yeah, you can buy one. I've not tested it yet, so I have to try to get one of those devices to figure out how they are working. But I think they are using the same techniques as already mentioned. So they're using here in this device, I think they have a network port here. I think they download the daily MFERIS files and using a GNSS antenna for that, and then calculating and looking up if the signal is valid or not, and then they make their suggestion about what can going on. Yeah, coming to the end, GPS attacks occurs often in case of jamming. Spoofing you will not see very often. By the way, in the Geneva Motor Show this year, someone spoofed the time and the place of all navigation system of the cars in the show. So all navigation system of the cars showed a place in England, in Great Britain, and the time was set to 2036. So nobody knows what it has to be, but yeah, it shows up that someone was spoofing the GPS signal at the Geneva Motor Show. Spoofing is not that easy, but it's possible. Yeah. Coming to the end, you find me under Twitter or under my email address, and I have to thank you to be here on my presentation.